All right, so today we are going to use our slope-intercept form to graph lines. All right, I'm going to try to do this pretty quick. You've got an assignment today, so here we go. So slope-intercept form is what we learned on Friday. It is the form of y equals mx plus b. It's the equation of a line for a non-proportional linear relationship where m represents the slope and b represents the y-intercept. The y-intercept, again, is going to be the variable b. Remember that it's an ordered pair where x is always 0, and it's the coordinate of a point where the line crosses the y-axis. It's the initial or starting value. Okay, so this is stuff that we did Friday. Just a quick little recap on identifying slope and y-intercept from these two equations. This one on the left is in slope-intercept formula. So when I set it up like that, the slope is going to be 4. The y-intercept is going to be 1. This one on the right, it's just reversed. So what you can do is, if you can identify it here, that's fine. But you could also rewrite it to where it becomes y equals, I like putting the slope first. I realized over here this needs to be b. I like putting the slope first, and that slope is a negative 3x. And then plus 5. So once it's in that slope-intercept formula, it's pretty easy to identify what we have. Negative 3 would be the slope, 5 would be the y-intercept. Okay, it's pretty straightforward on that. So here's what we do. All right, I'm going to do these two, and then you're going to do the next two, and then we'll do the backside. Okay? First thing that we need to do is identify which number is going to be our slope and which number is going to be the y-intercept, just like we did on the two above. So the slope in this problem is 1/3. The y-intercept is negative 2. When we graph, the first thing that you need to do is you need to plot the y-intercept. Okay? Start by plotting the y-intercept. Actually, I'm going to write that. Start by plotting the y-intercept. Okay, so on this particular question, the y-intercept is negative 2. So when we plot points, we always start from the origin. So we're going to start there, and we're going to go down 2. So that would be the y-intercept of negative 2. Now you remember slope. Slope is rise over run, right? So what we'll do is from our y-intercept, we are going to use the slope. As rise over run. Okay? Here's what I mean by that. Now, you don't have to typically drag, but I'm going to drag this just to show you visually. But my rise in this one is 1, so I'll go up 1. And then my run is 3, so I'll go right 1, 2, 3. So my next point that I have is right there. Now, technically, all you need is 2 lines. Okay? Or sorry, 2 dots. That's all you need. I could draw a line like this, and I'll move it because I can. And that's what my line would be. All right. But notice as you kind of look along these points, there are other points that this thing's going to go across. Specifically, there's going to be one right there. Okay. What you could do, we did on this one, we had a rise and a run of 1/3, right? But what you could do from the y-intercept is you could go down 1 and left 3 to where you have a -1 rise and a -3 run. You could do that. And sometimes you're going to need to go in the opposite direction that I taught you. It just happens. It depends on the numbers. Okay. The reason that this works is because since slope is rise over run, we would have a -1 over -3, and a negative divided by a negative still gets us a positive. So our slopes are still the same. Okay, but that's it. You just really need 2 points. I would encourage you to put more, just because the more points that you have, the straighter your line is going to be. All right? So that's the first one. I'm going to go to the right, and I'm going to do the same thing. All right? Now, there's a couple things. This is our second problem. There's a couple things that I want to point out. First of all, this slope is -1. All right? So the slope will be a -1. We can go ahead and identify that. The y-intercept is going to be 1. We can identify that. After we figure that out, we can put the y-intercept in, just like we did on the one to the left. Since the y-intercept is 1, you're going to go up 1 and put your dot right there on that y-axis. Okay? Now, the difference between this problem and the problem to the left is that the problem to the left had a slope that was already a fraction. So if we try to apply this slope of -1, we don't really know where it goes. We need 2 numbers, right? We need a rise and a run. All right? So what I'm going to do is make that into a fraction. And the way that you make these numbers, these whole numbers, into fractions is you put them over 1. So I'm going to put my -1 up here, but then I'm also going to make it into a fraction. So now I have a rise and I have a run, because that gives me the ability now to move from my y-intercept. I know that I'm going to go down 1 because my rise is negative, and I know I'm going to go right 1 because my run is positive. So again, what it will look like is I will start from here. I'll go down 1, and then I will go right 1. And that gives me a second point. And with this, since these guys are close together, I would continue to do this a few more times. So that's what I'm going to do. I'm going to go down 1, right 1. Down 1, right 1. Down 1, right 1. Not all of these dots are necessary. I'm just showing you. Okay? And again, like the one that I talked about on the left side of the screen, you can go in the opposite direction. So what I could do is instead of instead of having a -1 on, I guess I could just show you this. I could go up 1 for a positive slope or positive rise, and left 1 for a negative run. And notice that's going to give me a point there. So that slope would be a rise of 1 and a run of -1. But again, what it comes down to is that every fraction is a division problem, so our slope is still -1. It didn't change that. We just did it in the opposite direction. Okay, so I'm going to draw my line. Hopefully, nope, didn't work, did it? Hopefully, I'm hitting all of these lines, or these points. All right. When you make your lines too, please make sure that you go all the way across. Don't just go through the dots, go all the way across the screen. Okay? So I want you to work on the next two. All right? Pause the video, work on the next two, and then we'll come back. Okay, hopefully you paused the video. If not, buckle up because I'm doing this quickly. So my slope here is -3/2. My y-intercept is a 3. I'll start with the y-intercept of 3. This problem is similar to the top problem on the right because we have a -3/2. So this can either be seen as a -3 divided by 2, or it can be seen as a +3 divided by a -2. It's your preference, but that negative either has to go on top or on bottom. What I would do is, because I like dealing with my rise first, I'll do the middle one that I have. So I'm going to go down 3, 1, 2, 3, right 2. Down 3, right 2. You actually can't, not on this graph, you can't do that one on this graph, just because if we go up 3, we're off, and then we're somewhere over there. So it was good that I chose that middle one. So just again, make sure that your line goes all the way across like that, and that's your first one. Next one, slope is going to be 3. The y-intercept will be -3. So I will start with that -3 y-intercept. And again, I'm going to make this whole number into a fraction by putting it on top of 1. And that tells me that my rise is up 3 over to the right 1. Up 3 over to the right 1. And again, if I do it one more time, I'll be off the graph. But this is just fine for me. There it is. Okay? That's it. That's graphing slope using the slope and the y-intercept. All right? So let's go to the back side. Keep it moving. On this problem, or on these problems, these first 4 problems here, you have to solve for y first, and then you have to graph using the slope-intercept form. So this is what we did last Thursday, where y is not by itself. So just in case you've forgotten how to do that, I will remind you. It's not terribly difficult, but let me just show you real quick. All right? So when I'm solving for this, I'm going to subtract my 5x because I want to get 5 by itself. That will leave me y on the left side. You can't combine the 2 and the -5, so I'm going to put my slope first. That's a +2. So that would be my slope-intercept form. So the slope according to this form will be a -5. The y-intercept is a 2. I'm going to do just what I did on the front side. Start with the y-intercept of +2. Okay. And then my slope, I need to make it into a fraction, so I have a rise and a run. I'll do that by putting it on top of 1. And then just use it. So from the y-intercept, my rise is -5. So I'll go down 1, 2, 3, 4, 5. Oh, don't plot the point. Don't plot the point. 1, 2, 3, 4, 5. And then the run is 1. So it's just going to go to the right 1 point. That broke, didn't it? This pen. This pen. Pretty good line. Hopefully it's long enough to fit on the whole graph. There we go. Okay, there we go on that one. All right. Yeah, that one's done. Okay. The next one is, again, we still need to solve for the y. So rewrite this. I tried to give you guys enough space on this. I don't know if you have it. You might need an extra sheet of paper, but hopefully not. So here we have this. I want to get my y by itself. So first let me do this. Let me do that. And then I'm going to add the 1x to both sides. All right? Looks like an F. All right? Again, you cannot combine those like terms those unlike terms of negative 20 and positive 1. So I'm going to write this as 1x plus 20 and set that equal to 4y. Now that y is on a side by itself, but it does have that 4. So I need to divide everything by 4. Okay? When you do that, and I know you're probably running out of room, I apologize, you're going to have 1 over 4x, just leave it as a fraction. If you put it into a calculator, it will give you 0.25, and 0.25 you can't graph a decimal, so you need to convert that to a fraction. 20 divided by 4 is 5, and then 4 divided by 4 is 1, or just y. Now, like I said at the front of at the beginning of the video, sometimes you'll have the y on the right side. If you want to rearrange it, you can. But if you can identify what the slope and the y-intercept are, you can just leave it. It doesn't matter to me. From what we have here, the slope is going to be 1/4. It's good. It's in a fraction. My y-intercept is 5. Now I can already tell because I have a positive slope and my y-intercept is starting off really high. I'm going to have to do that reverse kind of applying slope. So here's what I mean by that. Your y-intercept of 5 is way up here. Okay. If I was going to use that slope of 1 over 4, I would go up and over, but I'm off. So what I'm going to do is I'm going to say that 1/4, I'm going to say we're going to go down 1 and we're going to go left 4. Because they mean the same thing. A negative divided by a negative is a positive. So I'm going to go down 1, left 1, 2, 3, 4. It's barely, way to go Moriarty. It's barely on the graph, but it is technically still on the graph. So that's what we have there. Okay. Go ahead and pause the video. Try the next two. Okay, hopefully we paused the video. I'm going to do this pretty quick. Maybe. So what I'm going to do is rewrite this. Negative 8x equals 10y plus 30. I really don't think I gave you guys enough room. I apologize. It's going to be negative 8x. Oh boy. Negative 8x minus 30 equals 10y, and then I need to divide everything by 10. And I know my line's not lined up with the equal sign. That was a room thing, but anyway. Negative 8 over 10, you could leave it as that, but I would definitely simplify it. Negative 8/10 simplifies to negative 4/5 x. Negative 30 divided by 10 is a minus 3. That's going to equal y. I'm going to keep it like this. I don't need to rearrange it for myself. So my slope is going to be negative 4 over 5. And like I said on the front page, you can pick if you want that negative to go with the 4 or the 5. It doesn't matter to me. Y-intercept is negative 3. So this is going to be starting at the y-intercept of negative 3. And then I think it would make sense for us to use, because we're already pretty low, I'm going to keep my 4 positive and my 5 negative, because we're going to run up 4 and go left 1, 2, 3, 4, 5. Okay? And that is a negative slope, which is what we wanted. Should be looking like that. All right. Over here, same thing. Got to adjust this, so this will be 6x minus 10y equals negative 40. Split it. Keep your y's where they are and subtract the 6x to get negative 10y equals negative 6x. How much room do I have? Minus 40. All right. Last step here is divide by negative 10. And that will get us y equals, a negative divided by a negative is positive. So that would be a 3 over 5x when you simplify that. Fix that. 3 over 5x. Negative divided by a negative is positive, so it's plus 4. So my slope, according to my equation, is 3 over 5. My y-intercept is 4. So start with the 3 over 5. No, lies. Start with the y-intercept of 4. 1, 2, 3, 4. And again, because of the way that this is, I'm going to 3 over 5 is the same as negative 3 over negative 5. So from here, I'm going to go down 3. 1, 2, missed it. 1, 2, 3, right. 1, 2, 3, 4, 5. No, that's wrong. I need to go down 3, left 5. I was going to say 1, 2, 3, 1, 2, 3, 4, 5. And I knew that was wrong. No, I didn't do it. I didn't do that on purpose. But I knew it was wrong because as soon as I looked at how I was going to end up drawing that line looked to me like it was going to be going down from left to right. So I knew it was going to be negative, which is not what our slope is. Our slope is positive on this one. Okay? So that's kind of it for these. There's 2 more that I'm going to do with you really quick because sometimes you might see these, and these are special equations. And what you'll see on this is, as you're looking at it, on the left one, there's no x, and on the right one, there's no y. And I don't want you to run into those and, panic, because they're really not that bad, okay? For my y equals 3, since you don't know what the change is, and there's no x values, what you can do, what I literally want you to do, if y is 3, that means that y is always going to be 3. So make some ordered pairs where y is 3. Okay? Our y is 3. And then you pick what you want. Now, we have a very limited space on this graph. Okay? So I probably wouldn't go higher than 5 or lower than negative 5. So what I might do, just maybe go 1, 2, and 3. All right? And then plot those points, and you'll see what happens is actually pretty interesting. So 1, 1, 2, 3 is here. 2, 1, 2, 3 is here. And 3, 1, 2, 3 is here. And hopefully what you notice is that you have a line forming. But specifically, the type of line that you have forming looks like this. And some of you guys recognize this. Hopefully everybody recognizes this. Okay? This slope, since it is flat, this slope is 0. It's a 0 slope. All right? It's flat. What is the y-intercept? Well, the y-intercept is still going to be across the y-axis. So in this case, since y is always 0, our line is going to hit that y-axis at 3. Okay? So that's the first kind of weird one. And the second one that we have is saying that x is -2. So you're going to do the same thing. -2, and we'll pick one. -2, and we'll pick one. -2, and we'll figure that out. And if you just want to go 1, 2, 3 on this as well, that's maybe what I'm going to do. Like that. Then you will plot those points. So we get the -2's here from x being -2. Just plot these points. -2, +1 is here. -2, +2 is here. -2, +3 is here. And again, you start to see a line forming, but that line in this case is a vertical line. So this one is going straight up and down like that. And if you recall from the practice that we've had on identifying slopes on IXL, this slope is undefined. And if you're looking at this, you can tell that that line is never ever going to go through this y axis. So the y-intercept, there's none. There's no y-intercept on that particular problem. Okay? So try the assignment, and I'm sure that we'll have questions. So when I get back, we will deal with that. All right? But other than that, I will see you guys next time.